Second thing, you've seen this idea espoused before. We're going to say that radiation is a surface phenomenon. Even though it is not, strictly speaking, it's a volumetric phenomenon. And what this essentially means is that if I take a solid block of concrete or something, there is obviously radiant energy that is emitted within the body, within the volume of this block. But we're going to say that it does not have enough juice to come all the way to the surface of the block. Likewise, if I have radiant energy incident on that concrete block, I'm going to say that this energy is going to be absorbed to within the first few micrometers of the thickness of the block. And so as a result of that, we are going to treat radiation as a surface phenomenon. It's taking place only at the surface. All the volumetric effects are neglected. You go to a higher level course like radiative heat transfer, then you start seeing those kinds of things creeping up. The fundamentals remain the same. The math is a little more complicated. So that's the second thing. The third thing, and I'll stop after this, is that radiant energy has two foundational dependencies. The first is the dependency on wavelength, and this is called as a spectral dependency. It's a function of wavelength, which is called lambda, and this dependency is called as a spectral dependency. What's the other dependency? Obviously, if there is a hot surface and I just stand beneath it and stare at it, as compared to taking the same surface and looking at it from a different angle, the amount of intensity that I feel on my face is going to be different. Which tells you that radiant energy also has a directional dependency. It's also a function of direction. And this is directional dependency. And to categorize directional dependency, we're going to make use of the spherical polar coordinate frame, where you're going to have the zenith angle theta and the azimuth angle phi. And we're going to make use of that and start defining a few things such as solid angles, intensity of radiation, intensity of irradiation, and then radiosity. And then we will be in a position to start looking at problems. Okay?
No.